Hi, I gave you some exam questions to have a go at for your revision, so this is how you do them. You can either do them with me and pause the video and sort of use me as a model of how to do it, or you can just do them, mark them, and with my answers and see how you get on. So this is a parallel circuit. We've got some cells here, we've got current here. The current splits here. 0.2 amps goes this way, 0.1 amps is going this way. So we've got a little split in our current. We've got a bulb there in parallel with a 60 ohm resistor. There's a potential voltmeter across there to measure potential difference, and there's an ammeter here. So remember, when we get to this point here, two currents are going to come back together and add together. Now, it says each cell provides a potential difference of 1.5 volts. What is the total potential difference provided by the cells in the circuit? So each one of these is 1.5 volts, and we've got 1, 2, 3, 4. So we're going to do 4 times 1.5, which equals 6. So our circuit has a potential difference, or it's providing a potential difference of 6 volts from the cells. Now, it says, what will the reading be on the voltmeter? So what we need to remember is our series and parallel rules. So you can write this down if you want. So in series, the current stays the same and the potential difference splits. And in parallel, current splits and the potential difference stays the same. We're looking at a parallel circuit here. So our current splits and our potential difference stays the same as the power supply. So what will the reading be on the voltmeter? Well, if this is 6 volts, then that's 6 volts, because all the electrons that come down here have all got 6 volts, and they only have one resistor to give that energy to. So it's 6 volts. Next, the current through the lamp is 0.2 amps. The current through the resistor is 0.1 amps. What is the reading on the ammeter? Well, the ammeter is here. So we've got 0.2 amps coming into this junction and 0.1 amps coming into there. So the total resistance on the ammeter is when they've added together. So our answer is 0.3 amps. Last section, use a phrase from the box to complete the following sentence. The resistance of the lamp is, and we need to use greater than, equal to, or smaller than. Now, if we look at the current flowing through, there's more current flowing through this one than this one, which means it's easier for the current to flow through here. That means if it's easier for the current to flow, you've got more current, there must be less resistance because it's easier for the current to flow. So our sentence here, the resistance of the lamp is smaller than 60 ohms, okay, because the current is larger. So resistance is smaller. Okay? And then these questions. Look, I've reminded myself to make a video on them. So, potential difference graphs. A student wants to investigate how current through a filament lamp affects its resistance. Use the circuit symbols to draw the circuit. We've got our power supply of 12 volts. We've got a variable resistor to change the voltage, although when you did the power pack, your power packs had variable resistors inside them, so you didn't need this. We've got our lamp. We want to measure the current through the lamp, so we put our ammeter in series, and then we want to measure the potential difference across the lamp, so we put our voltmeter in parallel. And it just says, describe how the student could use her circuit to investigate how current through a filament lamp affects resistance. Okay, So you use the variable resistor to change the potential difference through across the bulb. You measure the current with the ammeter and you measure the potential difference with the voltmeter. So 6 marks just for those 2 parts. Next, the student's results are shown in figure 1. Describe how the resistance of the filament changes as the current increases. So as current increases, the resistance increases. Use figure 1 to estimate the resistance of the filament lamp when the current is 0.1 amps. So get your... Oh, we can't get our ruler because look, the current is 0.1 amps. And that's here. So what we need to do is just try and extend the line and then read off what we get. 2, 4, 6, 7 is there. I'm probably going to go with about 6.8 ohms. It says the current potential difference graphs of the 3 components are shown in the boxes. Use the answers from the box to identify each component. So the one that looks like the S is the filament bulb. The one that looks like is a straight line is a resistor at constant temperature. If you change the temperature, as you'll hear about in the revision video, you change the resistance because you make it harder for the current to flow, so it wouldn't be a straight line. And then this is a diode. Current can only flow in one direction, this positive direction. For low potential differences and negative currents, negative potential differences, no current flows. Question 2. The graphs A, B and C shows the current through a component varies with potential difference. You need to match them up. So this one's the diode. That's the diode. Symbol there. The S one is a filament lamp. And the straight line is a resistor. It says each of the circuits J, K and L include 2 diodes. Which one of the circuits would the filament lamp be on? So you've got to follow the current round, okay? And current flows from positive to negative. So the current is going to flow around this way. So can it get through this arrow? Yeah, it's got to follow the arrow. So that's okay. It can go through here, it can go through here, it can go through here, and it can go through here. So it looks like J is the answer. Check the others. Positive to negative. Oh, it's got the bar there, so it's stopped. Can't go do that one. Positive to negative. Oh, yeah, it's going through the arrow, so that's okay. The arrow's pointing this way. However, the bar stops it there on that one. It's not.